Simple syrups are actually a little bit complex. Now, if you are just making them at home or in small amounts, none of this really matters. But if you want to understand how to manufacture them, how to make a formula that can scale from a small amount to a large amount in a factory, and you want to understand your cost of goods, then you need to know a little bit more about what goes into making a simple syrup in a predictable and repeatable fashion. So, simple syrups are going to be almost everywhere. In the cafe, that's going to be how you get from your regular latte to a vanilla latte. In the bar, this is how you're going to balance the acid and spirit in something like a gimlet. And so uh, these things have a wide range of applications. And so let's break down what they are, what they're made out of, how to make them, and how to scale that recipe reliably. So I've got an example right here. This is an excellent brand, Torani. This is their passion fruit flavor, and this contains cane sugar, water, citric acid, and natural flavors. So if you want to know more about citric acid, or acids in general, or natural flavors in general, look up my other two videos where I cover that. Right now, we're just going to talk about the sugar and the water. So every simple syrup is going to have those two ingredients, water and sugar. Now, it's important to also note here real quick that you need to heat it up. So the reason that you're going to need to combine those things and then heat it up is twofold. So you're going to do it for food safety reasons and also to make sure that sugar stays in suspension. If you mix them together cold, you might be able to get it to dissolve with enough stirring, but with time, it's going to start to settle out and separate. So you need to heat it up. The other reason is it's going to give you an opportunity to reduce the amount of things in there like yeast and molds that are going to reduce the shelf life, cause spoilage. You don't want those things. So without getting all the way into thermal processes for food safety, because that'll be a whole separate video, let's just go ahead and say you're going to combine those two and you're going to heat it up to 185 degrees Fahrenheit and hold it at that temperature at least for about 5 minutes. That's going to reliably produce a simple syrup that's going to hold itself together and have good shelf life for you. Now, that's all pretty basic. Let's talk about how to create the formulas and how to scale them reliably. Now, I always use the metric system for this, and there's a few reasons. And the first one is that it illustrates the relationship between volume and weight. So behind me I have 1 milliliter equals 1 cubic centimeter of water, which also equals 1 gram. And this is only true about water. You can also say that a calorie is the amount of energy that it takes to raise 1 cubic centimeter of water or 1 milliliter of water 1 degree Celsius. So that's kind of like the starting point. That's what underpins a lot of the measurements in the metric system, right? And so I'll use grams and milliliters when I'm making these recipes. Great. So really common simple syrup would have equal parts water and sugar. And I've seen a lot of recipes that are just like, oh, 2 cups of water, 2 cups of sugar. Again, that's great if you're just making it at home or if you're making it in small scale, but that cup of sugar isn't a reliable enough measurement. So I always go by weight with the dry goods and by volume with the water, because again, you're chasing an end volume actually, not an end weight. And with water, the milliliters and the grams are going to be the same thing. So when I say milliliters now, I'm going to be talking about the water. When I say grams, I'm going to be talking about the sugar. So in a 50 Brix solution, I should explain what Brix is. Brix is a way to measure how saturated and how sweet that simple syrup is. It exists on a scale of 0 to 80. And there's a few different ways to measure that. I'll show you the most basic one. This is an analog refractometer. So I'm just going to place your sample right here, drop this slide on it, then you look through it like a scope. And I can't show you on the camera, but there's a little scale inside here that shows you 0 to 30 for this one is its maximum reach. It'll basically put a line on that scale where the Brix falls, where the measurement falls for that sample. You can also use, and this is what I use, is a digital refractometer. So you're going to put your sample here and turn it on, and it's going to pass light through that sample, and it's going to measure like the resistance of the light in a way through that sample. You know, so if it was pure water, you would get a 0. Like distilled water would give you a 0 because there's like no resistance for that light going through it. But if you had the sample really saturated with sugar, like if it was half sugar and half water by weight, you should get 50 Brix. So that's Brix, scale of 0 to 80. It doesn't go all the way to 100 because there's a limit to how saturated these things can get, right? And again, a lot of simple syrups are going to be 50 to 60 Brix. But for simplicity's sake, let's talk about 50 Brix. Oh, there's one more way to measure it. This is fun. So this is a specific gravity cup. This is a precisely machined little vessel, and it will contain exactly 50 milliliters of water. And so if you fill this up all the way to the top and wipe it off and put it on a scale, after you tear out the scale, of course, it should weigh 50 grams because, again, milliliter equals grams when you're talking about water, right? But if it's not pure water, if you have a simple syrup in here, it's going to weigh slightly more. And so that difference in weight is described by specific gravity. So it's saying specifically how dense or what's the gravity of that mixture, right? So I can talk more about that probably in another video, but it's another great way to measure the sugar saturation or the saturation of anything in a liquid mixture. Great. So I said earlier that you're not chasing the end weight, you're actually chasing the end volume. So this is really important for manufacturing because at a small scale, again, if you're just making a couple bottles of this stuff at home, it doesn't really matter. But if you want to know how many bottles you're going to fill in a factory before you put down all the time and money and materials to fulfill that order on a new recipe, you need to have some math in the background, some way to know reliably about how much you're going to produce. And so the volume, the end volume is really, really important. And so as a developer or formulator, if I get a request that says, hey, I need this flavored syrup to be this Brix or have this many calories by ounce, you can do that as well. And I need this much of it. I can use some of this math that I'm going to show you to write a recipe, small at first, that I know is going to scale out to hundreds of gallons, fill the right amount of bottles, and I also am going to know what it costs. So I'm always going to start measuring my sugar in grams because sugar is sold by weight, not by volume. And you need to be able to establish your COGS, your cost of goods. And then you just having the cost of the sugar isn't enough. You need to know how many bottles you're going to be able to fill, the volume, in order to understand how much you need to charge for those bottles. Make sense? So let's get back to our 50 Brix, our half and half. It's really simple, and I'll show you why it gets a little bit complex. Now, it would be really easy to assume that if you have 100 milliliters of water and 100 grams of sugar, you're going to make 200 milliliters of simple syrup, but it's not true. The reason is, once that sugar gets into the water, it's going to actually shrink a little bit. It's going to become more space efficient, right? And so you have to do what I would call a dry weight to wet volume conversion. Now, this is going to be a little bit different for different sugars, right? And so if you're going to do this, I recommend you do some testing, use your specific gravity cup, and get this exactly right. But for the sugar that I've been using a lot, which is an organic evaporated cane sugar, the conversion rate from dry weight to wet volume is about 60%, right? So to turn that into a multiplier, it would be 0.6. And so that's this formula here. Volume equals milliliters of water plus grams, that's weight of sugar, times the percentage or the conversion rate. And so that's how you get to your end volume in a pretty predictable fashion. I'll also show you this here as an example of it. So here's 100 milliliters of water plus 100 grams of sugar times 0.6. That's the conversion rate, which is going to turn that 100 into 60. That's how you get 60 grams. It's going to be 60 milliliters when you end up in the simple. So that's how you end up with 160 milliliters of volume. So if you don't get that right, it's going to be really easy to throw off your costs, throw off the end result or end yield of your production run. Knowing that is going to empower you to make small batches reliably, accurately, and then scale them up. So knowing volume is really, really important. And so I've actually built several spreadsheets that take all this information and they just spit it out for you. So I can tell it, well, I need a 60 bricks recipe that's going to make 1 liter for me to bench it and try it out, right? And it's going to use this formula in the background and spit out the amount of water and the amount of sugar that I need. Super useful. I can't show it to you on this video, but if you guys comment on it, I can probably link it in there. So I hope that was helpful in understanding simple syrups and what they are, and I hope I impressed upon you that they're not actually that simple. It's a little bit complex. Have fun.